Hi, here is another video from Solverscape. We build scheduling solutions for problems arising in logistics and supply chain management. Today we are going to talk about the quarterly planner. Let's say you own a set of retail stores in a city. Each store has a set of departments. You want to create a 12-week staffing plan for the stores. You know the number of workers that each department in each store needs on each day of those 12 weeks. You have a set of worker types such that worker of a given type or skill level is eligible to work in a specific set of departments. A worker of a specific type can be hired either for 4 weeks or for 12 weeks at known costs. A worker works for 5 days in a week and then gets a 2-day off. The quarterly workforce planner finds a consolidated staffing plan that ensures that worker requirements in each department of each store can be met at the lowest cost. So how do we use the quarterly planning model? We do that via this application called the Solver platform. It acts as an interface between a user and the mathematical model. Data interchange between the user and the model occurs via Excel. A user fills a specific Excel template and passes the file to the Solver platform for processing. The Solver platform calls the specific model, gets the model solution, and passes it back to the user in Excel format. Let us look at a demo now. So here is the application, Solver platform. We have 3 tabs here: models, jobs, queue. Let's look at the jobs. We have the historical set of jobs here. Let's look at the job for a quarterly planner. So we have a lot of information here. Let's download this job in Excel format. Let's open this job. So this sheet now contains all the information that was not only given by the user, but also the information that was given back by the model, the solution information. So what did the user enter? We entered the parameters. So we have a 12, we want to plan for 12 weeks. Each week has 7 days and each work week has 5 days. Then we provided 2-day break after 5 days. Solver settings, we can skip them for now. Then we have the set of facilities here. We have 3 facilities and we provide the latitude and longitude for these facilities. Then we have the set of departments. This is just a toy problem. We just have 4 departments here. Then we have the worker requirements for each facility, department and day combination. Then we have the worker types. We have only 3 worker types here: junior, senior and expert. Then we have work plan type. So there's only a short work plan for 4 weeks and a long work plan of 12 weeks. Then we have the mapping between which worker type. Then we have the mapping between the cost of the hiring a given worker type for a short plan and a long plan. Then we have the mapping between the departments and the worker type. So a worker who is more expensive, which we call him the expert here, he can work in more number of departments. Then we have the set of workers here, along with the latitude and longitude of their residences. So we submit this information and get the information back from the model. And what did the model say? The model gave a solution with 192 workers at a total cost of around $589,000. So what does this solution look like? So all the other tabs here contain the solution information in detail, but it might be more interesting to look at the plots of these solutions. So here are the work plans that the model created. So some of them are 4 weeks long, some of them are 12-week long. So the model created a total of 191 or 192 work plans. So here different colors represent different facilities. So we try to not have too many switchovers across switchovers of facilities across consecutive days of the plan. Then we can also see which worker is assigned to which work plan. So we try to assign workers to work plans so that the travel time for the workers is minimized. Then we have the plot for how well we met the requirements at each facility. and each department. So here, for example, Handsome Lumber on day 0, we wanted 5 and we assigned 5, which is good. So we don't want to provide extra workers here. So you see, most of these cells are empty. So the model was able to minimize the number of extra workers while making sure that we are uh, uh, meeting the demand, at on in each hour. So the next question is, how good is this solution? So for that, we need to talk about one or two concepts. The first is the optimality gap. It is the difference between the cost of a given solution and the cost of the best solution. If the best solution has a cost of say 10 million, then moving from a solution with a gap of 11% to a solution with a gap of 1% will result in a saving of 10% or 1 million. Second thing that we have to know is the way the model solves this problem. So the model operates in 4 phases. In phase 1, we check if we can have a feasible staffing within the given budget. Phase 2, we create an initial set of work plans in which we are trying to find the minimum cost plan without worrying about the facility switchovers on consecutive days of a plan. Phase 3, we update the plan so that we can minimize the facility switchovers on consecutive days. Fourth, we assign workers to work plans so that the total travel distance for all the workers is minimized. So now if we want to see how the model performed in each of these phases, we go back to the Excel file and look at the tab solver statistics, and we find that for the cost, we find the optimality gap for all the 4 phases, and the initial plan generation, which is the one where we are actually minimizing the cost, we have a solution that is less than 1%. So in terms of cost, we are at within 1% of the optimal solution. Though we can improve in terms of the facility switchovers that are happening within different plans. But in terms of cost, we are at the minimum. So to conclude, the model can be enhanced to include complex business rules. We can also provide an API endpoint for this model. This model is based on a technique called mixed integer programming that it can be applied to large size problems with hundreds of workers and facilities. The information on optimality gap can lead to significant savings. ML AI based models provide quick solutions but without any information on the optimality gap. MIP models are best suited for planning problems that do not need to be solved in real time but involve upfront capital allocation. To know more about where we have applied our models, visit us at solverscape.com/case studies. For potential collaboration, write to us at contact@solverscape.com. Thank you.